In this lecture, we will learn about the strategy design pattern and how to implement it in Python. Strategy is a behavioral design pattern that lets you define a family of algorithms, put each of them into separate classes, and make their objects interchangeable. We use the strategy design pattern when we want to use different variants of an algorithm with an object, and be able to switch from one algorithm to another during runtime. We can also use this pattern when we have a lot of classes that only differ in the way they execute some behavior. This design pattern is also used when isolating the business logic of a class from the implementation of algorithms may not be as important in the context of that logic. We use the strategy pattern when a class has a massive conditional operator that switches between different variants of some algorithm. Let's look at the pros and cons of using the strategy design pattern. The advantages of using the strategy design pattern are that you can swap algorithms used inside an object at runtime. You can isolate the implementation details of an algorithm from the code that uses it. You can replace inheritance with composition. And you can introduce new strategies without having to change the context. The cons of strategy are that if you only have a few algorithms that rarely change, it could overcomplicate the program. Also, clients must be aware of the differences between strategies to be able to select the proper one. Let's learn how to implement the strategy design pattern in Python. We will create a class named context. Inside of this class, we will create a variable named strategy and set it equal to none. Then we will implement the init function, which will take in two parameters, self and strategy. Inside of the init function, we will set self.strategy equal to strategy. Then we will create a function named doSomeBusinessLogic that will take in the self parameter. Inside of this function, we will set result equal to self.strategy.doAlgorithm with a list passed in containing the numbers 1, 2, 3, 4, and 5. Then we will have a variable named resultString set equal to an empty string. For each element in result, we will concatenate the element cast to a string and then a space to our result string. Outside of the for loop, we will print out the result string to the console using Python's print function. Next, we will create a class named strategy, which will have a function named doAlgorithm that takes in two parameters, self and data. Since the concrete strategies that extend this class will implement this function, we will just use the pass keyword for now. After that, we will create a class named concreteStrategyA that extends the strategy class. Inside of this class, we will define a doAlgorithm function that takes in two parameters, self and data. Inside of this function, we will have a variable named list set equal to the data parameter passed into the function. Then we will sort the list using Python's built-in sort function. Finally, we will return the list. As you can see, this concrete strategy will sort the numbers in our list in ascending order. Next, we will have a class named concreteStrategyB that extends the strategy class. Inside of this class, we will define a doAlgorithm function that takes in two parameters, self and data. Inside of this function, we will create a variable named list set equal to data. Then we will sort the list using Python's built-in sort method. After that, we will reverse the list by calling list.reverse. And finally, we will return the list. As you can see, this strategy will sort the numbers in the list in descending order. Time to test our code. We will create a variable named context and set it equal to a context object with a concreteStrategyA object passed in. Then we will print out the message strategy is set to ascending order. Finally, we will call the doSomeBusinessLogic function on the context object. Now we will write code to test out our concreteStrategyB. We will set our context object to a context object with an instance of concreteStrategyB passed in. Then we will print the string strategy is set to descending order. Finally, we will call the doSomeBusinessLogic function on the context object. When we run the code, notice that the first strategy sorted the list items in ascending order. The second strategy sorted the list items in descending order, just like we expected. In the next lecture, we will learn about the template method design pattern and how to implement it in Python.